How do ceramics fail without warning? Imagine holding a delicate glass ornament and suddenly it shatters without any sign of stress or warning. That's how ceramics often break, abruptly and unexpectedly. Unlike metals that bend or stretch before breaking, ceramics are brittle materials. They don't show much deformation before they fracture. This means they can seem perfectly fine until the moment they suddenly fail. Ceramics fail because of tiny flaws or defects that are usually invisible to the naked. These flaws can be pores, microcracks, or inclusions that sneak in during manufacturing or handling. When stress is applied, these flaws act like tiny cracks that concentrate the stress at specific points. Once a crack reaches a critical size, it spreads rapidly through the material. This quick crack growth causes the ceramic to break apart suddenly. The failure process starts at microscopic flaws, which are like small weak spots. These flaws are often introduced during production, such as during mixing, shaping, or firing. Even handling or everyday use can add new microcracks or flaws. Because ceramics have low fracture toughness, even a tiny flaw can lead to catastrophic failure if the stress exceeds a certain level. When a crack begins to grow, it does so very fast. The fracture surface of a ceramic often shows patterns like mirror, mist, and hackle regions. These patterns tell us where the crack started and how it traveled. Since the crack grows quickly and without plastic deformation, the ceramic breaks suddenly without warning signs like bending or stretching. Two main reasons cause this sudden failure. First, extrinsic flaws such as pores, inclusions, or microcracks that are present from manufacturing or handling. These flaws serve as starting points for cracks. Second, even without large flaws, internal stresses or microscopic vacancies can cause failure through mechanisms like thermal runaway. This is when localized heating accelerates damage, leading to sudden fracture. Dynamic loads like impacts or rapid stress changes can also cause ceramics to fail unexpectedly. These conditions promote the growth and merging of multiple cracks, breaking the material into tiny pieces. This type of failure is different from static failure, where a single large flaw causes the break. Because ceramics are so brittle and flaw-sensitive, their reliability depends heavily on controlling manufacturing quality and understanding service conditions. Testing methods like flexural strength tests and fractographic analysis help identify failure origins and mechanisms. This information guides improvements in how ceramics are made and used, reducing the chances of sudden, unexpected failures. In essence, the reason ceramics can fail without warning is their brittle nature combined with microscopic flaws that grow rapidly under stress. This makes it essential for engineers to carefully control defects and design ceramics that can better withstand the stresses they face in real-world applications.